Okay, we had in the last class. So we looked at a few examples and we completed the proof chapter. If you have any questions, you can ask, or we will start with the new section on quantifiers. I hope you have your slides ready. Because I won't be displaying the slides. So we'll be starting with predicate logic, language of quantifiers, which is also very simple. Okay, in fact, it's so simple. I will ask you questions about the chapter before I teach you anything. So it's so simple. So the first question is, what is, if I say, just hold on. Don't worry about the slide number, because I'll be giving you, don't look at the slides, you might get scared. Okay, let's say x, I denote p of x as x greater than 15. Okay, what is p of 5? Is this true or false? I have 3 answers. Yeah, very good. 4 answers. It's 5. Okay, what about, very good, very good. What about p of minus 8? Also false. Okay, what of p of 20? True. Very good. Okay, so I didn't teach you anything. I didn't teach you anything yet. Let me ask you a more complicated question. So I have p of a comma b is given as a square greater than b square. What is this? Mashallah, mashallah. Very good. False. Because why is it false? Minus square greater than 2 square. Is this true or false? I just substituted in that. It's false. So the answer is false. What about this one? True, very good. Because minus 2 square is greater than minus 1 square. 4 is very good, Ali Habib. So that's it. You've understood maybe 10, 15 slides. Now, if you can look at the slides, we are on slide 6, slide 7. So this P is called a propositional function. Okay, P is called slide 7. It's called a propositional function. So some examples are given in slide 8. So you can look through that. So I hope that is clear now. It's so simple. Yes? Can I have one of you give me an example? Maybe Ali Habib. Can you give me an example for R? R ABC. Can you give me an example for R ABC? Ali Habib, just give me any expression that connects X, A, and B, and C. Okay, very good. So, and Ali Habib, he should not become a professor. He gives very interesting questions. Okay, so we have A times B is C minus A. So can you tell me what is this? Is this true or false? Muhammad Ali says true. Firas says true. Qasim, very good. Okay, so that's a complicated question that I asked you. That's a complicated question that I asked you. So is that clear? 8. Anyone who did not understand, please ask me. I'll explain it to you. Because I did not teach you anything yet. If any one of you has not understood, please ask me. Otherwise, we will move further. Yes, it's very simple, Faisal. Yes, simple math. Okay, so if you go to slide 9, you see compound expressions. Compound expressions like if we have p of x that is great with x greater than 0, we have p of 1 and p of minus 3. So what is this? Since p of 1 is true, because 1 is greater than true and false, so this is false. Yeah. Okay, so all the operators that we had learned previously in the previous section applied. So just go through slide 9 and see if you understand it. Very good, Sultan. So just go through. So you have the AND operator, you have the OR operator, you have the implication operator. I want you to just read that slide. Just read through those slides and make sure you understood it. Okay, so let's move on to the new section, slide 10, quantifiers. Okay, this is something that looks very, very complicated, but it's very simple. So this just means that when I say, for example, if I have p of x and x is greater than 0, okay, so this is something. So here I say x is greater than 0, I'm specifying this is one value. Okay, I can specify another value. Okay, but I want to know for many values of x. So I say, what about for all of x, where x is an integer, So is this true or false for all of x? Very good. Okay, for all of x, it is not true because we can take one integer. We can say minus 1. Minus 1 is not greater than 0, so it's false. So for it to be true, it has to be true for all the integers, which is not true. So this is false. Okay, so this new symbol is called for all values of x. For all values of x, what is p of x? It's false. What about for some values of x? What do you think? For some values of x, this is true because it's true for minus for 6, for example. For some, this is true. Okay, that's it. These are quantifiers. It tells you the quantity. We have two quantifiers. We say for all or for some. Even if it's true for one value, it is okay. So that's all. Quantifiers. Is that clear? We have two quantifiers, this and this. Okay, now let me change the problem. I will not change the left part. I will change this. I'll say x is a positive integer. I say x is a positive integer. So I said x is a positive integer. Now what about this one, this expression here? Expression 1. Is it true or false? It will be true because for all positive integers, it will be true. So this value changes because I changed the domain. I changed the domain of x. Now for all positive integers, x is greater than 0. So it is true. What about the next expression, the second one? For some positive integers it is true. Think again. For some it is true. For 6 it is true. For 7, for some it is true. Or there exists, for some, or there exists at least one x. There exists at least one x where the expression is true. So for this also is true. Okay, because we can take an example. 6 is greater than 0. So there does exist one integer. There exists one x. We have one example of x where that one is true. So we say true. Why all p is true? P of x is true, Muhammad Ali, because what are the values of x over here? If x is a positive integer, 1, 2, 3, 4, regardless till infinity, you take all of them. For all those, x is greater than 0. 1 is greater than 0, 2 is greater than 0, 3 is greater than 0, 4 is greater than 0. So that's why for all values of x it is greater. It is true. Is that clear, Muhammad Ali? Okay, let's take another example so it becomes clear. So I'll take another example. We say q of x is represented as x plus 1 equal to 0. So for all, and the domain of x is 3, 5, 1, minus 1. Okay, so in the domain I don't have x as all integers. I have x can take only 4 values. Okay, now for all of x, q of x, is this true or false? It is false. We know it's false. Why? Because 3 plus 1 is not 2. So for all it is not true. For all values of x it is not true. But what about for some x, q of x? It is true. Mashallah, mashallah, very good. Very good. I see many of you awake today. And Ali Habib is so awake he answers 2 times for the same questions. MashaAllah. Okay, so this is all true. Why? Because we need one value that satisfies x. 3 plus 1, no. 5 plus 1 is not 0. 1 plus 1 is not 0. But minus 1 plus 1 is 0. So we say this is true because there exists at least one value of x which satisfies that equation. So is that clear for all and for some? We can also use simple examples. For example, m of x. X is a mortal. Mortal means bashar. Okay. Is this true or false? Very good. It's true. What about this? It's false. So we can use this as a math expression. You can use it as a logic English. So it doesn't really matter. So these are some examples. Okay. So for example, we can have a crazy statement like this. What do you say for this? Okay, so okay, okay, very good. Okay, so very nice, Firas. It depends on the person. Okay, cat lovers will think this is true. Firas does not like cats. It is false for him. Okay, so this is a relative question. So Firas, it's false, which is the correct answer for him because he probably does not like cats. And Qasim, Muhammad Ali, Sultan, Firas, most of you said true because you like cats. You say X is cute. So do you understand this one? So I might not agree with this. The cats are not very really cute near my house, especially near the garbage bin. So what about this? Okay, this will probably be true. There may be one cat in the world which is true. So for some cats, okay, Firas says true. Okay, so he likes cats. Ali Habib also says he likes cats. So some cats are true. Okay, so now I think you understand these two operators. There is another crazy operator which we'll not look at, which is this. Okay, so is this true or false? This new operator is, it says there exists only one cat which is cute. Okay, so this is talking about a single value, only one which is true. Okay, so let's take a mathematical example so you understand it better. Okay, so where x, the range of x, the range or domain of x is integers. So x can be any integer. So is this true? Is this true? Okay, why is this true? Why is this? Oh, Muhammad Ali, small mistake. Yeah. So there is only one value of x which satisfies this equation. There's only one value of x which satisfies this equation. So this is a uniqueness quantifier. This is optional. If you don't understand it, it's okay. It's a optional slide. Okay. So there are two ways of looking at it. Say for all. No, it will not be in there in the exam, Muhammad Ali. Optional slides are not included in the exam. Okay, so when I say for all, it means for all the values that x can take. So we take the first value of x and it should be true for the another value of x and the third value and till the last value. Only if all these values are true, only then will the for all expression be true. Okay, but the for this one I check if it is true for this or true for this or true for this or true for this. So I check it till the last. Okay, so when will the first expression be true? When will the first expression be true? Very good, Ali Habib, very good, very good. When all are true, only then the first expression will be true. Yes, Firas Sultan, when all are true, true and true and true. Even if one of them is false, it cannot be false. It cannot be true. So I stop. I don't need to check. Okay, for example, let's say um, x is from Taif in my class. Okay, the domain is x are students in my Cpcs222 this section. Okay, so to evaluate this, the first expression for all p of x. So I start with each one of you. I go to Ali Habib. I say, Ali Habib, are you from Taif? He says, then I have to go to the next student. No, he's from Taif for this class. Then I go to Sultan. Sultan, are you from Taif? He says yes. Then I go to Firas. Firas says no. I'm not from Taif. Now, should I continue further asking the other students? I don't need to. The moment one student says I'm not from Taif, this will become false. This will be false even if one student is from Taif. Okay, but for making it true, I have to check all the students. I have to ask each one of you. But for making it false, if like Ali Habib said, I'm not from Taif, so I stop. I don't need to ask anyone else. This expression is false. But for the second expression, I spoke about for all now, Muhammad Ali. For all, at least all have to be true. But for at least, okay, at least is true or false. I go to Ali Habib. I say, are you from Taif? He says yes. So should I ask anyone else? I no need to ask. I just stop there. I got one student and it's true. I just stop. But to make it false, to find out if it's false, I have to ask all the students. Only if all are false and no one is from Taif, then I can answer this. So it's like a loop. Okay. So for all, I have to make sure it's true. I have to check with all integers or all the whole domain. But for false, one is enough. And there there is a opposite case. For making it true, I need just one example. But for showing that it is false, I don't need to check all. I need to check all to make it false. Is that clear? Okay. So after you understand this lesson, you can look at the slides, then it makes it clear. Muhammad Ali, you have a question? Muhammad Ali Al-Ghamdi, you have a question? You can ask. All. If one is F, then it's all F. Yes, very good. For some, if one is true, then all is true. Very good. Yes, very simple. You have summarized it to check. Okay. So now when you look at the slides, everything becomes clear. Can you go to slide number 15 and take the first example? Okay, so we have P of X is given as, it's given as X less than 2. And the domain is usually specified with the capital U. This is the domain. Okay, I'll remove the brackets to confuse. This is the meaning of U. The domain is all positive integers. All positive integers. So for all of X, P of X, is this true or false? Okay, most of you are saying false because it's not true, because all positive integers are not less than 2. 1 is less than 2, but 2 is not less than 2. So this is always false. What about this? Very good. For which value? No. Yasser? Yes. So for 0 and 1, for 1 it is true. So that is enough. Okay, Yasser, why did you say 3 for some? Or was that answer for the previous one? Yasser Muhammad Zahrani. Okay, no problem. So I hope that slide is clear. So please look at example number 2 and example number 3. So the domain is changed. Only the domain is changed. For example number 3, the domain is 3, 4 and 5. And P of X is given as X greater than 2. So is this true for all P of X? Is this true or false? It is true because 3 is greater than 2, 4 is greater than 2, 5 is greater than 2. So we checked for all. True and true and true equal to 2. Very good, Muhammad Ali. So this is true. What about this? Also true, because we need only 1. 3 is greater than 2. That's it. I stop. Okay, so do you understand? This is the domain. So if this domain changes, my value changes. Okay, for example, let me change the domain. Now domain is all negative integers. All negative integers. Now what is for all x p of x? False and false and false. Yes, so this is false. And there exists one x. Okay, also false. Okay, so if you see this, it's the same expression. Okay, same expression and same questions, only the domain has changed. So it's very important that you know the domain. Okay, I'll ask you a very tricky question. Okay, p of x is x minus 1 greater than 5 for all x p of x and for some x p of x. Okay, what are the values? Very good, very good. Firas and Sultan and Muhammad Ali and Yasser. Unless you know the domain, you cannot answer. Okay, so I think you have understood it very well, the quantifiers section. Okay, so domain is important. Unless I provide you the domain, you cannot tell me whether it's true or false. X could be positive, X could be negative, X could take a few values. So for these quantifier questions, you have to have the meaning of or the domain of X. Okay, so I want you to read those slides. Now look at those slides. All of those slides will make sense. Okay, the chapter is very simple, but if you look at the slides, you will get very scared. So start from slide uh, 3. So this is section 1.4. So just read through and see if you have any questions. Till slide 15. Go till slide 15 and see if you have any questions. Okay, Ali Habib, for now, think of those as separate statements. We will revisit that later on. Okay, it's nothing, it's just two statements. So I'm saying P of X is X greater than 2 and Q of X is or uh, X plus 1 equal to 2. These are two statements. All men, all men are mortal, and Socrates is a man. Do you understand, Ali Habib? Yeah, it's basically that. For all, and here we are talking about a particular element. So in this maths example, we are saying for all x p of x and then p of minus 1. So here we are talking about a particular element like Socrates, and here we are talking about the entire quantifier. So those two statements are that. Okay. Any other question? Just read through. So here in this case, M says M, we have like M of X means X is a mortal. X is Bashar. X is a mortal. Any other question? Read through till slide 15. Slide 15 is very simple. Slide 16, it just gives the precedence of quantifiers. So if you have the and or mixed with for all, so make sure you do the for all or there exists first before you expand the operator. So it's just a precedence. So if you have something like this, for all x p of x and q of x, so you first evaluate this. This has higher precedence. After you evaluate this, you get true or false, then you do the and. Okay, so precedence. Okay, slide 17, we looked at slide 17, it's and or is for some. Slide 18 also is just the same example we have looked at. So we looked at all these slides. We took different examples and we looked at it. We looked at this also, slide 20. But we will not start with slide 20 now. So till here we will stop till slide 18, slide 19. Any questions? Okay, then we will stop for today. If you have any questions, you can send me an email. Inshallah, we'll start with the next portion from my slide 20 in the next class. But basically, you have to understand that the slides and the textbook sometimes look very complicated. I don't know why they've been designed that way, but they're very, very simple. Put this in your head that all these slides are simple and that I have to get an A plus in this course. Okay, if you miss a class or if you're not with me in the class, because some of you are probably turn on the blackboard and go to sleep or chat with your friends, because in the last class also we found out with the poll that many students are not with us. So those students will have problems in the midterm and the final, because it's the slides, if they try to study, they're very scary looking. So please make it a point that you attend the class regularly, ask me questions, and when I give you some problems, try to answer it. Even if it's a simple true and false answer, answer it. So it gives you more confidence. And if you give wrong answers also is okay, because I'll know you haven't understood and I'll call out your name and explain it to you uh, such that you understand it better. So I know whether my students have understood or not understood. But if they're silent, I will not know whether they've understood or not understood. So I want you to help me, and together we can have a good knowledge sharing. Okay, that's all for today, and I'll see you in the next class. Assalamu alaikum wa rahmatullahi wa barakatuh.